Alright, we're going to be looking at arithmetic with polynomials today. Polynomials, holy smokes, what did that mean about it? Well, I'll tell you about it. But first, let's get into it a little bit. First, let's define monomial. A monomial is a single term. You often hear it called a term instead of a monomial. And a monomial is quite simple. It's a constant, so a number, a variable, a letter or symbol, or a product and a number of one or more variables with whole number exponents. Okay, so that's all it is. And so if we look at the following, we can determine how many terms there are. Okay, how many terms does this show? Hopefully you got that it's a single monomial because it is the product, see, note right here, the product of a number and one or more variables. Try this one. How many terms are there here? Well, there's a single term, right? There's a single term, x to the third. Okay? How about this one? I bet I got you there. This is still one term. Because remember, one term is the product of a number and one or more variables. Multiplication is a product, which means this is one single term because it's the product of a constant and variables. One term here. You could also write this term as 3x squared y. But writing it differently doesn't change how many terms it is. It's still one term and still one monomial, regardless of whether it's written this way or the way down below. How about this one? That's two terms, right? Because this term right here is x times x. It's a variable with a whole number exponent. And this one has a constant and the product with a variable being multiplied. Okay? How about this one? Also one term, right? You have a -3 times x times t times h. That's the product of a number and one or more variables. Also one term, right? This is the multiplication, the product of variables. So hopefully you're seeing that a lot of these things that you might look at and say, oh, there's two different things there. It's actually one thing if they're all being multiplied. Okay? So now let's talk about like terms. What makes things like terms? Okay, like terms or like monomials are ones that have the same variables raised to the same power. The constant in the front doesn't matter so much, but the variable and the exponent of the variable matter very much. They definitely do, because you can't add together things that are not similar, right? If you've got different boxes, if you kind of think of it this way, if you've got different boxes, if they're all the same size, if they're exactly the same thing, then you can put them together. The problem with the variables is we don't know how big they are. So the only way that we know if they're the same size if it's exactly the same variable with exactly the same exponent, because then that box will be exactly the same as any other box that has the same variable with the same exponent. Now, we'll look at a couple of situations where we can do that. So if they are like terms, you can add and subtract them. You can put them together by just adding and subtracting the constant. The box, right, the variable and the exponent isn't going to change. What is going to change are the constants, the coefficients that are associated with those variables. All right, so here we go. Lastly, you cannot ever add or subtract unlike terms. If the boxes are different sizes, right, if the variables or if their exponents are different, you cannot put them together, ever. I don't care what level math you're in, you will not be able to combine those things because a variable is unknown and you can't put things of unknown sizes together if they're not the same. All right? So let's look at a couple examples. We're going to be asking, are these like terms or not? Here's the first one, 5x and -3x. Now remember, like terms have the same variable, same power. So here you got an x, no exponent, but we understand that that's an exponent of 1. And here we have an x with a variable of 1. That makes these like terms because they have the same variable and each of those variables has the same exponents. All right, so those two things, the 5x and the negative 3x, could be added or subtracted together. How about these two? Are these like terms? Well, hopefully you said no, because these, yes, they have the same variables. They have x and y, but those variables aren't raised to the same power. This one has an x squared, whereas this just has an x. This one has a y, where that one has a y squared. So those boxes are different. The unknown part of it is different, and so that makes them not like. They're not the same type of monomial, and therefore they aren't like terms. So you could not add or subtract those together, ever. Okay, how about these? They got the same exponent, but it's not the same variable, so they are not like terms. You cannot add those or subtract them, ever. Okay, how about these? Okay, good. They all have an x. They all have the third power, which means they all have the same variable raised to the same power. If you wanted to, you could add these together. You could subtract them. That is okay because they are like terms. All right, how about these two? This one is very, very important because if any of you ever try to put these together, I'm going to hunt you down. All right? X squared has a different exponent than x. Therefore, they are not like terms, and they cannot ever be added or subtracted. Please do not do it. All right? Here we go.